Question 4a, determine the first three terms of the expansion 1 minus 8x raised to the power half. So now we have a power there that's a fraction. We can use 1 plus x to the power of n is equal to 1. We only want the first three terms. So 1 plus nx plus n into n minus 1 x squared over 2 factorial. So in this case, we are 1 and we replace x now with negative 8x. N will be the power there half. So that's 1 plus n is the power of half times minus 8x plus n, that's half, into n, so half minus 1 x squared. So this, but we're replacing x with negative 8x, so negative 8x all square over 2 factorial, which is 2 times 1. So this is equal to 1, and then half times minus 8, that's minus 4, so minus 4x. And here we have negative 8x squared, that's 64x squared. So this part is 64x squared, and then over 2, and here we have half minus 1. Half minus 1 is negative a half times half, so that's negative a quarter. So this will become 1 minus 4x. So 2 into 64, that's 32. 32 times negative a quarter, that's negative 8, so negative 8x squared. So those will be our first three terms. Hence, by letting x equal to 100, determine root 23. Okay, so we just wrote 1 minus 8x to the power of half, at least the first three terms, as 1 minus 4x minus 8x squared. So if we let x be 1 over 100, that's what, 0.01. Then what we'll have here is, in the bracket, is 1 minus 8 over 100, right? 1 minus 8 over 100 to the power of a half will become 1 minus, if x is 1 over 100, so 1 minus 4 over 100 minus 8, 1 over 100, all square. So this will be, in the bracket, what we actually have here would be 1 minus, this is what, 0.04 minus, and is actually 8 times 0.01 square, and that will work out to be 0.9592. Now over here, 1 minus 8 over 100, this would be 1 minus 8 over 100 is actually 92 over 100 to the power half. And what we could do is take the square root of both numerator and denominator. So that's root 92 over root 100, which is 10. And of course we can rewrite root 92 on the left hand side, we can rewrite root 92 as root 4 times root 23 over 10. And then root 4 is 2, so this is 2 root 23 over 10. We have 0.952 here, 0.9592, and this is 2 into 10, that's 5, so this is root 23 over 5, 2 into 10, 5, 2 into itself, 1, so root 23 over 5 equal 0.9592, and of course now we can multiply both sides by 5, since we want root 23, so both sides by 5, so root 23 is equal to 5 times 0.9592, which would be equal to 4.796. Part C. Use the intermediate value theorem to show that the equation has a root in the interval 0, 1. So we want to find, we can let f of x be equal to 4 sine 2x plus x cubed minus 3. So we can find f of 0. So f of 0 would be equal to 4 sine 0 plus 0 minus 3, which would be equal to negative 3. And we can find f of 1. F of 1 would be equal to 4 sine 2 plus, replacing x with 1 cube minus 3, which would be equal to 1.64. So since f of 0 times f of 1, so now f of 0 times f of 1 is equal to minus 3 times 1.64, which is obviously a negative number. It's less than 0. So therefore, by the intermediate value theorem, abbreviating IMVT, intermediate value theorem, a root lies on the interval 0, 1. In other words, a root lies between 0 and 1. So the root would be, to the equation, of course, is 0 point something, since the root is between 0 and 1. Alright, let's continue. Use 3 iterations of the interval bisection method and obtain an approximation for the root. So let me just remind ourselves what the equation was again. F of x was equal to 4 sine 2x plus x cubed. What was it? Let's remind ourselves. So 4 sine 2x plus x cubed minus 3. Now remember we found, we found already that the root is between 0 and 1. So we're going to use 0.5 as an approximation, the midpoint of 0 and 1. So we're going to use 0.5 as an approximation. So we're going to find, so we're going to find f of 0.5. So remember f of 0 was negative 3. And f of 1 was 1. So f of 0 was a positive value. F of 1 was a negative value. So we know the root lies between 0.10 and 1, which was a midpoint 0.5. So let us find f of 0.5. So f of 0.5 is equal to 4 sine 2 times 0.5, which is 1, plus 0.5 cube minus 3. Let us use our calculator to calculate that. This is equal to 0.49. So f of 0.5 give me a positive value. So the root, now we know the root lies between 0.5 and 1. Alright, so let us try the midpoint of 0.5 and 1, which will be 0.75. No, I think I have it all wrong. Actually, f of 0 was negative 3. F of 0 was actually negative, and f of 1 was actually positive. And we want f of 0.5 to be positive. So we know the root lies between 0 and 0.5. So we find the midpoint of that, which is 0.25. So let's find f of 0.25. So f of 0.25 will be 4 sine 2 times 0.25, that's 0.5. So sine 0.5 plus 0.25 cube minus 3. Let us use our calculator to work this out. That's negative 1.07. So f of 0.25 is a negative value. So we know the root lies between 0.25 and 0.5. So we find the midpoint of that. To get the midpoint, we add 0.25 and 0.5 divided by 2. We get 0.75. 0.75 divided by 2. That's 0.375. So now we're going to find f of the midpoint of that. F of 0.375. So that would be 4 sine 2 times 0.375. That's 0.75 plus 0.375 cube minus 3, and that is equal to negative 0.22. I think we can stop now. We're asked to do three iterations. Negative 0.22. So this is a negative number. So we know the root lies between, this was 0.375. We know the root lies between 0.375 and 0.5. So I will take the midpoint of 0.375 and 0.5. So approximation to root is 0.375 plus, is it 0.5 plus 0.5. Do we average those? And we end up with 0.875 divided by 2, 0.44 to 2 decimal places. Next, use iteration x subscript n plus 1 equal to sine n. So let me just rewrite it. So x subscript n plus 1 equal to sine x subscript n plus 2 all over 3. Now the initial approximation, we can call it x0, x subscript 0, where 2 is equal to 1. And so x subscript 0 will occur when the n is 1. So x subscript 1 would be equal to sine x subscript 0. So let n be 1. Alright. Plus 2 over 3. And of course x subscript 0 is 1. So it's sine 1 plus 2 over 3. That gives us 0.947. And then x2 will be sine subscript x1. So this time we'll let the n be 0. So here we'll let the n be 0. Here we'll let the n be 1. And of course this n is 1 and 1, 2. So alright, and so sine subscript 1, sine x subscript 1 plus 2 over 3. This time we're letting x1 be 0.947. So it's sine 0.947 plus 2. That would give us 0.937 when we divide by 3. And then so next, so this time we'll let n be 2. So x subscript 3 now. So 2 plus 1, that's 3. So x subscript 3. And so it's sine x subscript 2, which we just found, to be 0.937 plus 2 divided by 3. So it's now sine 0.937 plus 2 divided by 3. That would give us 0.935. Let's see, let's try one more. So this time we can let n be 3. So this time we find x subscript 3, which is equal to sine x subscript 3, x subscript 2, sorry. Yes, sine x subscript 3. So x subscript 4 now we're finding. Because yes, 3 plus 1, 4. So x subscript 4. So sine x subscript 3 plus 2 all over 3 is equal to sine 0.935 plus 2 divided by 3. Again, we get 0.935. So I think I'll stop here since we're still getting 0.935. So therefore the root is 0.935. Let's continue. So now we're at question 5. Statistics. A bag contains 4 golf balls and 2 other balls, whereas a box contains 2 golf balls and 3 other balls. A fair coin is tossed, and if the result is head, a ball is drawn from the bag. Otherwise, a ball is drawn from the box. Represent the possible outcomes of a single trial of this experiment on a tree diagram. So this is a little bit tricky. Let's read over again and try to make sense of it. And while we're doing that, let's see if we can do the tree diagram simultaneously. So they're asked to do a tree diagram. All right. Notice at the end. Let's start from end there. A fair coin is tossed, and when if a coin is tossed, there are 2 results, right? So if we toss a coin, we have 2 possibilities. We can get either head or tails. Right? And the probability of getting a head is a half, and the probability of getting a tail is also a half. All right. A bag. So let's go again. So if the coin is tossed, if the result is a head, a ball is drawn from the bag. Otherwise, a ball is drawn from the box. If the result is a head, a ball is drawn from the bag. Otherwise, a ball is drawn from the box. And we have 2 types of balls. We have golf balls, which are in the bag. 2 other balls. So in the bag, we have 6 balls. And in the box, where the box contains 2 golf balls, in the box, we have 5 balls. So in the box, we have 5 balls, right? So the bag have 6 balls, the box have 5 balls. All right. So, and the 2 type of balls is golf and other. So of course the 2 type of balls is golf. Put golf here. And other. So those are the possibilities. Golf and other. So let's see now. Let's read again. If the result is head, a ball is drawn from the bag. So if the result is head, a ball is drawn from the bag. If it's drawn from the bag, it could be 4 golf ball. So 4 over 6 or 2/3. And the other would be 2 over 6 or 1/3. All right. So otherwise, which means that If it's head, I would draw from the golf bag. If it's head, I would draw from the. No, otherwise we're drawing from the box. So if it's tail, we draw from the box. Now if we draw from the box, the possibility of getting a golf ball, 2 out of 5. That means the chance of getting other balls, which would be 3 out of 5. Alright, so again, so full understanding of the question. So you could draw head, you flip a coin, it would be head or tail. If it's head, you draw a ball from the bag, and you have 4-6 chance of getting a golf out of the bag, and a 2-6 chance of getting another ball. If it's tail, we'll draw from the box, which means there's a 2/5 chance of getting a golf, and a 3/5 chance of getting other. That's if you get tail. And tail means you're drawing from the box. Head means you're drawing from the bag. So that would be our tree diagram. Next, determine the probability that a golf ball is drawn on the first trial. So let's go back to the diagram. A golf ball is drawn. For a golf ball to be drawn, it means that, so golf ball would be half times 4/6. So that's half times 4/6. Let's go golf again. Half times 2/5. So half times 4/6, what's that? So half times 4/6, that's 2 into 4. 2/3, that's 1/3. And half times 2/5, that's 1/5. So the probability of getting a golf would be 1/3 plus 1/5. So 1/3 plus 1/5, which would be, of course, 8/15. Next, a group of 12 persons are to travel in 3 cars. Each car can seat 4 persons. In how many ways can the group be seated in the cars if 2 particular persons refuse to travel in the same car? Alright, so let's read again. A group of 12 persons are to travel in 3 cars. Alright, let's do a little sketch here. So we have 3 cars. So car 1, car 2, and car 3, right? So we have 3 cars and 12 persons. So in the first car, we have 12 persons. So in the first car, we can choose 4. In the second car, we already seated 4. So 4 persons are already seated. 4 persons are already seated. So in the second car, we have seating 4 more. So 5, 6, 7, 8. All right, and 8 remaining. So it's 8. And from the 8, we're choosing 4 persons. And in the final car, of course, person 9, person 10, person 11, person 12. So 4 persons, we're choosing 4. All right, so we can add. So we can add these. So number of ways. So the number of ways the 12 persons can be seated will be 12 choose 4 and 8 choose 4 and 4 choose 4. So we can use our calculator to do that. Will be, that give us what, 34,650 ways. Now let's look at the restriction. So the restriction is that now this is we can see them in 34,650 way if there are no restrictions. So let's put no restrictions. So what we really want to calculate is the number of ways the group can be seated in the 3 cars if 2 persons refuse to travel in the same car. So let's look at the calculation where the two persons are actually traveling in the same car. So the number of ways, the 12 persons can be seated. Number of ways the 12 persons can be seated if two persons are always traveling in the same car. Let's do that calculation. Now, let's do a diagram to represent this situation here. So remember, we have 3 cars. So we have 3 cars traveling, 12 persons. So we have 3 cars, right? If 2 persons always want to be traveling in the same car, it means for the first car, it means, let's say for the case here, let's say this is the first car. So this is the first car. Let's say 2 persons definitely want to travel in the first car. So in this first car, you're really only selecting, there are 2 persons seated here. So you're really only selecting 10 from 10. You're only selecting 2 from 10 for the first car. Because after 12, 2 is already fixed there. So you're choosing really 2 from 10. And then in the second car, in the second car, again, 4 persons, so you're left with 8 persons, because 4 already seated and it's 12. So you're left with 8 persons and you're choosing 4. And the final car, the last 4 persons, you're seating them 4 different ways. Alright, well, there's 4 choose it 4. So 4 out of 4. Now, the other situation is that the 2 persons, they want to travel now in the car 2, car 3. So what could happen is it's the same process now, but this time we seat them in car 2 first. If we seat them in car 2 first, same thing. Car 2, let's say we fix 2 persons in car 2. You're really selecting 10, 2 from 10. 2 choosing 10. And the same way, you'll be left with 8. So we have 4 persons now in car 2. And then now, so car 2, so in this case we have car 2. And then the other car 1, you'd place now, H choose 4 in car 1. And in the final car 3, still 4 choose 4. Right? Or you could seat them first in car 3. You could seat them first in car 3. So car 3 here, where you select the 10 choose 2. Alright, so you fix these 2 here, 10 choose 2. Because remember, it's 12 persons. You fix 2, so you're really selecting from 10. And then, again, from the other cars, same whichever way you want, the car 1 or car 2 next, is 8 choose 4 and 4 choose 4. Alright? So again, you could start the selection. You could fix them in car 2, so you start with 10 choose 2. Then you see the other persons, 8 persons in the other 2 cars. Or you could seat them first in car 2, then in car 3. Alright? So the number of ways to do this calculation will be what now? 10 choose 2 times 8 choose 4. So the ways would be 10 choose 2 plus 8 choose 4 plus 4 choose 4. And remember, this can happen 3 different ways. So you could do this for start the seat in car 1 first, and then car 2 next, and then car 3. Alright? So we multiply that by 3, because I can do this 3 different ways. Either you're going to fix them in car 1, or fix them in car 2, or start the fixing in car 3. Alright? So this becomes, so use my calculator to do this. So this is 3150 times 3, and I end up with 9450. So to answer the question, In how many ways can the group be seated? If two persons, in how many ways can the group be seated if two persons refuse to travel in the same car? This would be equal to the number of ways without any restriction, and we just work that out to be 34,650. All right, there it is, and this is without no restrictions. And with the restriction, the number of ways would be 9450. So we take the difference, 9,450, and this should give us, calculate, this should give us 25,200. On a table, there's a space for 10 books out of a total of 16 available books. However, a Bible and a book of ghost stories must go at the ends. So let's do that. So it's a space. So on a table, there's a space for 10 books. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. However, a Bible and a book of ghost stories. So a Bible. So you have a Bible here, and a book of ghost stories must go to either end. By the way, either, so we could do it, let me do it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We could put the ghost stories here, and the Bible here. Alright? In how many ways can the books be arranged on the table? So we have 16 books, and we're really fighting for 8 spaces. Alright? So so actually, yeah, so 16 books. 16 books fighting for, well, actually it's 14 books, because the Bible and the ghost stories book, these are fixed. So it's really 14 books you have really, because these are fixed. Either Bible go at the front or Bible at the end. Ghost stories at the front or ghost stories at the end. So it's really 14 books now fighting for 8 places. So 14, pick 8. Alright, and we're talking about things here, so the order is important. So we use P, and of course, 2 possible ways. So of course, we multiply that by 2, because remember, the book can be at the front, or the Bible can be at the front, or the Bible can be at the back. And of course, order is important. Since we're talking about things, it's not like the previous question with the car and the persons. Alright, so 2 times 14, P8, and of course, we can use our calculator to do this. This is 242,161,920. Alright, let us continue. So a matrix problem. A system of linear equations with unknowns x, y, z is represented in the following augmented matrix. By reducing the matrix to row echelon form, show that the system has a finite set of solutions. So we want zeros to be leading the second and the third row. So we can change row 2. So row 2 can become row 2 minus 2 row 1. And row 3 can become row 3 plus 2 row 1. So we end up with, alright, let's put back row 1. So 1, 1, 1. Alright, 3. And row 2 now, we're subtracting 2 of row 1 from row 2. So it's 2 minus 2, that's 0. 0 minus 2, that's negative 2. Minus 3 minus 2, that's minus 5. And minus 16, minus 2 times 3, so minus 16 minus 6, that's minus 22. And then row 3 will become row 3 plus 2 or row 1, so negative 2 plus 2, that's 0. Negative 1 plus 2, that's 1. 3 plus 2, that's 5. And 15. 15 plus 2 times 3, so 15 plus 6, that's 21. Now if we look carefully, we can get a 0. The second row, we want another 0 in the second row. So we can multiply row 3 by 2 and add it to row 2. So we can change row 2 by allowing row 2 to become row 2 plus 2 row 3. Alright, so let me just write back row 1 and row 3. It's row 2 I'm going to change now. So let me write back row 1. Row 1 is 1, 1, 1, and then 3. Row 3 would be 0, 1, 5, 21. So row 2 now becomes 2 of row. So I'm going to double row 3 and add it to row 2. So a double 0 plus 0, 0. 2 and negative 2, that's 0. 10. So 10 and negative 5. That's 10 and negative 5. That's 5. Double this, double this. So 42 minus 22. That's 20. Alright, so if you look at x, y, z. So if you look at row 2, if you look at row 2, if you look at row 2, 5z is equal to 20. Divide both sides by 5. So z is equal to 4. If you look at row 3 says y plus 5z equal to 21. So y plus, we just found z to be 4. So y plus 5 times 4 is equal to 21. So y is equal to 21 minus 5 times 4. That's 21 minus 20. So y is equal to 1. And then for the top row, x plus y plus z is equal to 3. So x plus y plus z is equal to 3. So x plus, we just found y to be 1 and z to be 4 and z to be 4 is equal to 3, which means that x plus 5 is equal to 3, which means x is equal to 3 minus 5, x is equal to negative 2. So that's our solution. X equal negative 2, y equal to 1, z equal to 4. Question 6. A differential equation is given as dy by dx plus tan x minus 2y cos square x is equal to 0. So I'm going to rewrite this. And so write this dy by dx tan x plus y. And I'm going to use the integrating fraction method. So I'm going to add 2 cos square x to both sides. So I group it here. So 2 cos square x. And now I want dy by dx by itself. So I'm going to divide through it by tan x. I'm going to divide through it by tan x. So divide the first term by tan x. I'm left with dy by dx. And divide y by tan x. So that's y over tan x. And divide 2 cos square x by tan x. So it's 2 cos square x divided by tan x. Alright, so I divide each term by tan x. I'm left with that. So the integrating factor is equal to e to the integral of the coefficient of the y. And the coefficient of the y is actually 1 over tan x. So 1 over tan x dx. And of course 1 over tan x is actually cos x over sin x, right? So this is integral of e to the cos x over sin x dx. And I integrate this, so it will be e to the integral of cos x over sin x, that's log sin x. And e to the log sin x is equal to sin x. So we can times, we're going to times now each term, times each term now by sin x. So we're going to end up with sin x dy by dx, so times the equation, this equation by sin x. So end up with sin x dy by dx plus sin x y sin x over tan x. So sin x over tan x times y, and then we're about this, so this will be 2 cos square x tan x, and of course I'm multiplying by sin x, so times sin x. So times sin x times each term there in the differential equation. Can I simplify this? Let's try and simplify this. So this is actually sin x dy by dx plus, now what is sin x divided by tan x? Now sin x divided by tan x, so sin x divided by tan x is actually sin x, remember tan x is sin over cos, so it's actually sin x times reciprocal of sin over cos, that cos over sin. Alright, so sin x divided by tan x is actually cos x, so cos x times y, so that we're at y cos x equal to, let us also work out the right hand side, which is 2 cos square x, so it's 2 cos square x times sin x divided by tan x, so it's times divided by sin over cos, so times cos over sin, and sin into sin 1, so this is actually 2 cos cube. This is really 2 cos cube x. So we can now integrate both sides with respect to x. Alright, so we can integrate both sides with respect to x. So integrate the left hand side, we're left with y times the integrating factor of sin x equal to the integral of 2 cos cube x dx. So to integrate 2 cos cube x dx, what we can do is rewrite. So we can rewrite 2 cos cube, take out the 2, and rewrite cos cube as cos x times cos square. And we know cos square is 1 minus sin square x. Good? So it's cos x, rewrite the cos cube as cos times cos square. Cos times cos square. Remember, cos square is same as 1 minus sin square. Right? So this is y sin x equal to 2, and we can expand. So this would be cos x minus cos x times sin cube x dx. So it become y sin x equal to 2, integrate cos, we get sin, and integrate actually this is cos times sin, so this is actually sin square. So integrate, we can just add 1 to the power there, so integrate with sin x to the power of 3 all over 3 there, right? Plus our constant. And we can now distribute the 2. So we can divide each term by sin. Divide each term by sin. So we end up with y equal to, if I divide both sides by sin, y equal to 2 divided by sin with anything in the bracket by sign, end up with 1 minus sine square x over 3 and divide c by sine, so end up with c over sine x. And if we want, we can expand the bracket, so we have 2 times 1, 2 minus 2 sine square x over 3 plus c over sine x. Now, based on what we're asked to prove, that this is what it's equal to 1/3 cos 2x c cos x. Let's see if we can get that. Now, to get this, we can put, this is what, 2 over 1. So we can make it the same denominator as this. So we can times 3, so 3, and then times 3. So this becomes 6. So same common denominator here, 3. So we can put the numerators together. So this is 6 minus 2 sine square x all over 3 plus, and this is c over sine, that's c cosec. So c, this is c times cosec x. The reciprocal of sine is cosec, right? And we know 1 minus 2 sine square is cos 2x. So this 5, this 6, we can write 6 as 5 plus 1. And we have a minus 2 sine square x all over 3 plus c cosec x. Now 1 minus 2 sine square, that's cos 2x. So it will become 5 plus cos 2x all over 3 plus c times cosec x. So this becomes, we can separate the numerators, so 5 over 3 plus 1/3 cos 2x over 3 plus c cosec x, and that's what we're asked to prove. Hence, determine the particular solution given that y of pi over 2, given that y of pi over 2 is equal to 0. So remember the equation, let's restate the equation. The equation was y equal to 5/3 plus 1/3 cos 2x plus c cosec x. So when y is 0, so when x is pi over 2, y is 0 and pi over 2 is equivalent of 90 degrees, right? So replace the y with 0, so 0 equal to 5/3 plus 1/3 cos pi, so cos 2x, so that will be cos pi plus c cosec x, so it's c, and c cosec x is c over sine, so c over sine pi over 2. And we know pi over 2, so 0 equal to 5/3. And we know cos pi, what's cos pi? Cos pi, that's -1. So it's negative, a third times -1, so that's -1/3. Plus, and sine pi over 2, that's 1. So c over 1, that's c. So 0 is equal to 4/3 plus c. So -4/3 is equal to c. So the particular solution, so we have a c value, so the particular solution is y is equal to 5/3 plus cos 2x over 3 minus c and c, so minus c, so 4/3 minus 4/3 cosec x. Next, determine the general solution of the second derivative, so it's a second order differential equation, plus 2y plus 5y is equal to 0. So we can get the equation m squared plus 2m plus 5 is equal to 0. And of course, with this can be factorized easily. Can it be factorized? No? Can be factorized. So we'd have to use the quadratic formula. M equal to minus b plus or minus square root b squared minus 4ac all over 2a. So, alright, so we're trying to solve the characteristic equation here. So m would be equal to minus b, that's minus 2, plus or minus square root of 2 squared, which is 4, minus 4 times ac. So a is what? A is 1, a is 1, c is 5. So minus 4 times 1 times 5, that's minus 20, all over 2a, all over 2. So this would be equal to, so this would be m equal to minus 2 plus or minus root minus 16. That's 4i. Root minus 16 is 4i. A complex number there over 2. So therefore, m would be equal to divide by 2. So minus 1 plus or minus 2i. Alright, so the roots are complex. So the solution is y equal to e. Remember, for the second order homogeneous is e to the alpha x. In bracket, we'll have, in bracket, we have c1, constant 1, cos beta x plus constant 2 sine beta x, where in this case alpha would be the negative 1. This is alpha is the negative 1 and beta is the 2 there. So this would be y equal e to the minus x c1 constant 1, or constant times cos beta there will be 2, so cos 2x plus constant 2 sine 2x. Of course, where c1 and c2 are constant, so where c1 and c2 are constants. Hence, determine the solution of the boundary value problem to this the equation we just solved, where this is saying when x is 0, y is 1, also when x is equal to pi, y is equal to 2. So we can plug them into the equation. Let's remind ourselves what the equation is again. The solution was again. The solution was y equal e to the minus x c1. So they're asking basically first to find the constant. c1 sine 2x plus c2 cos 2x. Alright, so when x is 0, y is 1. So we can replace the y with 1. And if x is 0, we'll have e to the power 0, which is 1. And if x is 0, e to the power 0 is 1. Sine 0 is 0. So in the bracket, we'll actually have c2 cos 0. right? And cos 0 is 1, so the actual cos 0 is 1, so we actually have C2, so C2 is equal to 1. Alright? And also when x is 2, when x is, so this what you used to for this substitution, let's do the substitution when x is pi, y is 2, so replace now y with 2, x is pi, so we'd have e to the minus pi, when x is pi. Now sine pi, sine 2 pi is 0, so what you have here is 0 here, plus c2 cos 2 pi, cos 2 pi is 1, so that would be c2, cos 2 pi is 1, right? So 0 plus c2, so this becomes 2 equal to, expand z equal to e to the minus pi times c2. Divide both sides by e to the minus pi. So we end up with 2 over e to the minus pi is equal to c2. So there seems to be a problem here. So we have the second constant equal to two different things. So I guess there's no specific solution. So we have c2 is equal to, so we have c2 equal to 1 and c2 is also equal to 2 over e to the minus pi. Which one do we use? Alright, so we should just leave it like that.